Hey guys, in this video I'm going to show you how to use Vernier Video Physics to track the motion of an object, such as hypothetically this squash, hypothetically. Now, we're not going to be doing an experiment with a squash, we're going to be doing an experiment with tossing objects up in the air. And you may already have recorded the videos that you're going to use in Video Physics itself, in which case it would show up here on your list of experiments. But if not, you can import it from your camera roll by hitting the plus button up there. So we can take a video or choose existing. Means it's going to let us look at our camera roll and find a hopefully useful video like this one right here. All right, now let me just play the video so you can kind of see what's happening. Whee! There goes the ball up the ramp, stops perfectly at the top, falls back down. Awesome. Okay, now what Video Physics is going to do is allow you to plot the position of the ball as a function of time. First thing would be find the first moment, if this is the experiment I'm doing, right, where my hand is no longer touching the ball. So you can, move this thing back and forth with your finger, but you can also advance one slide at a time by hitting the 1 down there at the bottom. All right. Now, I'm picking this as my starting moment for the experiment because my hand is no longer touching the ball. Therefore, I can consider this to be the moment of, call it, initial velocity for the ball. I'm no longer pushing it, it's only gravity acting. All right, now there's these crosshairs here. What the crosshairs do is they tell the app where the ball is positioned. So if I put them, say like, I don't know, here on the ball, I might say that's the center of the ball. The ball is kind of a blur right now, so it's a little hard to tell exactly where it is, but I'm going to say that that's where I want the app to think the ball is, and then you tap in the middle of it. Boop. And there's a dot that appears. And then the video automatically advances to the next frame, and I repeat that process, right? I move the crosshairs until I say that's where I think the ball is. All right. And then repeat. I'm just going to do this a whole bunch of times, right? Just boom, boom, boom. Trying to identify where the ball is. Ideally, you spend some time and get it carefully lined up, right? But there's a certain amount of visual estimation involved here. That's okay. You can be a little off. Just keep doing this until we've gone through the whole video. Well, that took a bloody long time, but I've got all my data points, and now I am ready to proceed to the next step. The up and down motion, by the way, is the most complicated because it has the most data points. So don't imagine they're all going to be this bad. Just the up and down, and only if you roll it all the way up and all the way back down like I did. Our next step, though, is we've got to set the origin and scale. That's this thing up here. So let's poke origin and scale. And what this part of the app allows you to do is set a scale for the motion of the object based on some observable object in the room that's in the same plane as the moving object, meaning it can't be further away or closer to the camera. Well, I'm going to use the track as my scale, which is going to work pretty well for me since the ball is moving parallel to the track. It's also probably going to work pretty well for you for the exact same reason. If you had the short metal track like this, it was 1.2 meters long. If you had the longer track, that one was 2.2 meters long. If you had one of the plastic tracks, I don't think anyone did, but if you did, those were 1.5 meters. Okay, so 1.2 meters. Now my scale is appropriately set. All right, now the origin is adjusted with this thing. For what I'm going to do, I'm going to pick this end of the track as my origin. And I can adjust which direction the x-axis is in. Normally don't touch this, but for this lab, you will. We're going to move this thing around to tell it which way the x direction is. put it like, oh, there we go, parallel with the track, and see how that looks. What I'm expecting to see is the ball rolling uphill and then downhill, right? So it should look like a concave down parabola when I look at my graphs. I can see my graphs by poking this. All right, that's what I'm expecting to see. That's good. That's a good graph. And these graphs should be nonsense. The only ones I really care about are x position and x velocity. Okay, so it's not the concave down parabola that I was hoping for because I filmed my video from left to right, unfortunately. It's okay. Just go with it. All right, if yours looks like that, don't worry. It's not a huge problem. All right, so we're going to say done. Our next step is we've got to export this data into the Vernier Graphical Analysis app. So poke the export button at the top right, and then you want to select the .cmbl graphical GW format. It might not appear up here. It doesn't for me. But if I poke open in, graphical GW is this one on the list. And so I'm going to open it in that app. Oh, and look, there, some graphs. Most of these are nonsense. This is not a good thing. If you print it like this, I'm going to be real upset. Okay, I don't want any of this stuff or most of this stuff. Make it a little more simple. We'll poke that button up there, which allows us to reformat things. I want one graph at a time. I want only one thing to display at a time. There, that's much better. This is the graph I want, or one of the graphs I want for this motion. So now that I've got it, I'm gonna screenshot. Okay, I can now select my x velocity, unselect my x position, and that's the other graph that I want, and I will screenshot. All right, that process that I went through start to finish, if you recall, had to pick all my data points. That took a little while. Set my origin and scale by telling the video how long some object was so that it could correctly scale the motion of the tennis ball. Tilt my axis if necessary. Probably is necessary, but might not be if you filmed from some other angle perhaps. And then export the files into the Graphical Analysis app. Get your x position and your x velocity graphs, screenshot them, and print those out, bring them to class. That's for each of the 3 videos. So that means that you're going to arrive in class with 6 graphs, 2 for each of those videos. All right, if you have any questions, please send me an email. I hope that helps.